Welcome to Module 4. This module is all about the inference function. This is the piece of code that hooks directly onto the event hub, takes in the incoming package, and then makes a prediction on that package and drops that to a SQL database, as well as pings the live feed to the website. So that's how we're getting the feed here, where we've got 1283 bad widgets, 20,000 widgets, and we can start doing roll-ups, and we're getting, serial numbers with good, bad, so forth and so on. The reason I wanted to look at this first is this is our continuous integration pipeline. There's from a pipeline perspective for the inference function, there's two. There's the continuous integration and the continuous deployment. For now, we're just going to look at the integration. Specifically, I want to look at this bash script. What we're doing here is that we are creating a new folder inside of the directory structure of the inference function. It's called process telemetry. We're making a folder for this AI_ACC_quality. That's the name of the distributed package. The reason we're doing this is because as of today, which is September 12th, 2019, private PyPy cannot be installed via a requirements.txt into an Azure function. As such, we need to get our distributed package into the function somehow. That way we can take advantage of the machine learning capabilities that are baked into it, as well as the data modeling capabilities and the data connectors. Remember, we built that package as a code once, distribute many. So we've put a lot of the things that could potentially be used multiple times into that package. And the inference function is one of those locations where we are going to be using those. So we do a recursive copy from the location of the distributed package in our GitHub repo, which I'll pull up in just a second, and we place that into the process telemetry folder location. Now, if we take a look at our GitHub repository, we have SRC as a top level folder. Inside of SRC, we have the individual folders for a complete package or deployable, independently versionable, releasable piece of our software. So kind of like a microservices, but all in one GitHub, so that's easy for people to kind of check out and find. The inference function is one of those. The distributed package, we click on that inside of SRC here. You see we have the AI_ACC quality, and then we have connectors, data models, and ML. So from there, let's take a look at how we use this thing. The first thing is function.json. Function.json defines the kind of inputs and outputs via bindings that we have. So here we have an event hub trigger, and it's an in direction, and it gets its connection from an environment variable called event hub's connection string using a default consumer group. So it then also has an init.py. So let's take a look at the init.py. This has one function in it, and basically we've tried to separate it out so it's a little bit easier to separate kind of the interface for Azure Functions from code that I'm providing. It's looking for one thing in particular. It wants an event, it wants a function called main that takes a parameter called event of the type event hub event. Because we're doing JSON, we can call getBody decode UTF-8, and we're actually going to get a JSON string out of that. So run. This is important. Relative imports. The Python Azure Functions runs on relative imports. It's actually not appending the path of your location of your directory to its Python path. So if you did an absolute import for run, you're going to fail. It can't find the run. So you have to do relative imports. So you can see these are failing because I didn't want to copy that folder structure into my local. Otherwise, it's going to get a little bit hairy. So I'd have two versions of the distributed package. So I do that in the continuous integration. So what we have here for run is, this is also relative imports, by the way. This is our main entry point. So it gets the event JSON, and we have brought in a series of capabilities from the distributed package. This is really nice. So I get to have a widget classifier machine learning model. I don't really need to know too much about how that thing works. I get a widget, which is my domain model, and I get a database connection and a table connection. So when I get that JSON in, I just can create one of these widgets from that JSON, widget.widget from JSON. That's great. My distributed package is already going to work for me because I can use that code in a variety of places. Primarily the other place is going to be the web application. If I want to have my machine learning capabilities and model, because I have placed that into a distributed package that can be used in a variety of places and it has a known interface with it, I just create one of these classifiers and I load the model. And it knows how to do all of that on its own. All that logic is baked into the distributed package. I want to be able to make a prediction on it. Widget classification equals classifier.predict. Look at that, and I just pass it a widget. It knows how to transform from a widget into its own machine learning compatible format and get a prediction out for me. That's really, really cool. I'm just making up a standard deviation distance. That's because we had to swap algorithms like I mentioned in the machine learning section. So if the widget classification is good, is false, that means it was a bad widget, this is an anomalous widget, we're going to post this bad widget to the web. So what does this do? It gets the URL location for the website Signal.io server endpoint. And then we're going to use the widget to convert it back into JSON with the classification and just make a post call to that URL with the JSON. And then the website knows how to handle the incoming JSON format from the widget. This is part of why it's important to have a distributed package, because now the logic for converting this object to JSON and then converting it from JSON back into an actual domain object is all contained in one location and tested in one location. If you were to have just coded this here, you're going to be maintaining conversions from JSON and domain objects in two different places, and those objects likely don't even look the same, and it's just very error prone. So anyways, that's pretty nice. So we post the bad widget to the website. That gives us that live feed. So if we go up and check out here, this anomaly feed, when a bad widget gets processed, it gets posted here. So I'll kind of put this off to the side to see if we get one during this time frame. It's 1 in 100 and it takes a little while to generate one. So we'll see if we get one in this time period. The next thing is that widgets know how to persist themselves to SQL and to table storage just given a connection. So we grab the database connection and the widget knows how to persist itself to SQL and it knows how to persist itself to table storage. Again, the widget also knows how to grab itself from SQL and grab itself from table storage. And that's it. That really simplifies our inference function quite significantly. The bulk of the logic for this thing really isn't inside of the inference function itself. The bulk of the logic is in that distributed package. I wanted to have most of that in the distributed package just because it's a single place to test things, and it's going to be used both in the inference function as well as the web application. And it makes the facilitation code of like what I'm actually doing look significantly simpler. So our inference function totals out to be 37 lines of code, while the first 10 lines of code are comments and import statements. So really it's 27 lines of code to achieve that objective, and it's very simple and easy to understand. Let's go ahead now and take a quick look at the Azure Portal for the inference function. This is nice. This is where we get to see our function. So there's a lot of reliance on environment variables. So the first thing we need to do is go to our top level function and click on configuration. Inside of configuration, you'll see there's a whole bunch of parameters here. So some of these are going to be provided for us. So App Insights Instrumentation Key, Azure Web Job Storage. I highly recommend using the version of functions with App Insights, even in your dev environment. It is so hard to diagnose an issue running in this environment if you don't have that turned on. I'm going to show that up next. Like, that is so critical. You really want that. Things that are ours for control are the Event Hub connection string, Event Hub path, the SQL DB driver password server, all these things. So these need to be set to your values. I don't use the connection strings very much. These, anything inside the app settings, these are stored as environment variables. And also what's cool is that you can override those locally using this dev.env as long as your settings in VS Code calls out that the python.env file is workspace folder /dev.env. So workspace folder being inference function, dev.env. Don't check your dev.env into GitHub. That's going to have a lot of passwords in it. Don't do that. Bad idea. So here inside of monitor, we can start seeing some of our successes and failures. So you can see while I was trying to diagnose some of these issues, primarily relative imports, I had 59,000 failures. That was really good though, because I don't know if I can click on it and see the failures, but it would give me really explicit output, an output that was recorded through logging. So like completed widget with the widget serial number, if we take a look at the logging inside of our run function, you'll see that we have logging.info completed widget. I have logging.info processed anomaly widget. When it encounters an exception, if you have this app insights turned on, like inability to create an import, it will give you the stack trace that you would normally get from a print statement as a logging.error. That's phenomenal. So logging.error, string E. Once I did that, that allowed me to see exactly the issues that were occurring and be able to diagnose those and then get a fix into production significantly quicker. Well, that concludes this particular module for the inference function. The next module is going to be for the distributed package. If you're wondering how you actually do the machine learning capabilities and how do you load and do all that inside of a package, stick around for that. That's coming up next. Thank you very much.